Okay, so let's get into the exercise. So question number one, it says for the following experiments find the probability in each case, and the first experiment is from a box containing orange flavored sweets. Bilal takes out one sweet without looking. Events that are happening, like what is the probability that the sweet is orange flavored, and what is the probability that the sweet is lemon flavored. Okay, so first let's identify the sample space, which is the set of all the possible outcomes. So it's a box of orange flavored sweets. It doesn't matter how many. It could be 1, it could be 10, it could be 100, right? I'm just gonna like suppose that it's like it has 10 orange flavored candies, let's say, or sweets, right? So let's say like O1, O2, O3, all the way to O10 are within the box. So now, to find the probability of the sweet being orange flavored, let's call it like event A, like the probability of event A taking place is equal to like which sweets are orange flavored, all 10 of them, right? So O1, I'm gonna have to move this bit down, I think. Anyway, O1, O2, O3, all the way to O10 will be orange, right? So like that they're all included in event A. That means the number of elements in event A will be 10. So the probability of event A taking place is equal to number of elements in event A ratio number of elements in event what's it called, sample space, sorry. By the way, I forgot this, but like the number of elements in sample space will be 10 in this case. So when we go back down there, we get like a 10 over 10, right? 10 out of 10. So like if we cross, we get 1. 10 ones are like 10. 10 ones are 10. So like basically the probability is a 1. That means it's like guaranteed. It's 100% chance that we will get an orange flavored candy. And now what is the second part? The second part asks what is the probability of there being a a lemon flavored candy. So let me choose the color. Oh, that's not the color. This is the color. Okay, so number 2, I'm gonna name it event B is equal to we will call it event B is an empty set, you could say, because, well, there is no lemon flavored sweets, right? So it's an empty set, meaning 0, like 0 we can say. So yeah, other words, like you could say number of elements in B, event B, are 0. So the probability of event B taking place is, well, equal to number of elements in event B ratio number of elements in sample space, which will be equal to 0 over 10, which will be 0, because, well, yeah, whenever something divides 0, you get 0. So that means that it's impossible for us to get a lemon flavored candy because, well, there are none, duh, because, well, it's an orange flavored sweets box, or a box of like orange flavored sweets, so makes sense. Anyway, yeah, so that's pretty much the first question. Now let's move on to the next question. So what does the second question say? So question number 2, we have, like, the second experiment is Pakistan and India play a cricket match, and the result is, like, the events that are happening are that Pakistan wins or India does not lose. So, like, what is the probability? You could say it's asking. So, like, it's Pakistan versus India, and like they're playing a cricket match. So like first of all, what is S? Like, what is our sample set? S. What will S be equal to? Well, if you look at it, there are two teams playing, right? So there are three possibilities. Now you might ask, three? What? What do you mean? I mean that either Pakistan wins, either India wins, or either they have a draw. So that's like three possibilities, as you can see. One, two, three. So three possibilities, total possibilities. So like that is our sample space. And what is the first, like, what is the first event? The first event, yeah, I'm gonna use this, I think, yeah. Event number one is that I'm gonna name it event A, is that PK wins. So this is like a event. And like, how do we like find the probability? Well, PK wins, that's like one element, right? So n of A is equal to 1, right? And like I forgot to mention up here, but I'm gonna write it right here. N of S, or number of elements in S, are 3. 1, 2, 3. India wins, Pakistan wins, or it's a draw. So those are three total outcomes, right? And like the number of like elements or particular outcome that we're concerned with is PK wins in the first case. So n is of A is equal to 1. So P of A, the probability, let's choose this. The probability of A is equal to the number of A divided by number of S, or like all outcomes. And I'm just gonna maybe move this bit. Yeah, and yep, I think we're all good. So yeah, this is the formula, and putting the values inside the formula. N of A is 1, and we know that N of S, the number of elements in S, are the sample space are 3. So the probability of Pakistan winning is 1/3, according to, you know, like this the information that we are given. So now let's move on to the second event number 2. I'm gonna use this. So event number 2 is India does not lose. So now India doesn't lose. Okay, let me just write that. Let's call it event B. Event B is equal to India doesn't lose. So what does this mean, that India doesn't lose? This means that either India wins or either it's a draw. So I'm gonna just write it. Event B is equal to India wins or it's a draw. Because if you think about it, either, since India didn't lose, either it had a draw, it didn't say Pakistan won just because India didn't lose. So either it could be a draw or India might have won. So there are two possibilities, you could say, when we say India didn't lose. So in that case, the number of elements in B are going to be 2. So to find P of, oops, I almost wrote A. To find P of B, we need to divide the number of elements in B by the number of elements in the sample space. So that is 2 over 3. So P of B is 2 over 3. And yeah, that's like our second question done. And yeah, now let's move on to the third question. Alright, so what is question number 3? Question number 3 is there are 5 green and 3 red balls in a box. One ball is taken out. What are the event, like you could say, what's the probability that the ball is green, and what is the probability that the ball is red? Well, first of all, let's like identify the sample space. What is a sample space? We have, I'm gonna like name the balls according to the, like, you could say their color, right? So like G1 for green one. Oops, what did I do? I'm supposed to use the green color. This one, G1. I think this. Yep, yeah. G1. Oops. G2. G3. G4. Oopsies. G4 and G5. And then we have over here red, R1, R2, and R3. So like we have, there are 5 green and 3 red balls in a box. So there we go. Yes, I did this on purpose, if any of you are wondering. But at the level that we're at, I don't think you guys will be, but still, I mean, yeah, so let's just like continue. So the like the sample space is like made up of, you could say, 8 balls, right? Because 5 green balls, 3 red balls, so that makes 8 balls. So n of s will be equal to 8. Number of balls in sample space are 8. And now let's find out the chances that the ball is green. So I'm gonna write like event A again. I'm naming it event A. I know it's kind of lame, but yeah, actually maybe we'll like switch it up in the next question. Anyway, event A is that the ball is green. The ball is green. So the ball is green. Now, like, the ball is green. How many balls? Like, just saying. Let's write that again. Event A is equal to, like, there are 5 green balls, so it could be any one of those green balls, right? So that means G1, G2, G3, G4, G5. I'm kind of clumsy, but anyway, forgive me for that, well, you guys. Anyway, we have event A. It's like equal to like G1, G2, G3, basically every ball that's green. That there are only 5 balls that are green. So yeah, so that's event A. Event A consists of G1, G2 in the green all the way to 5. So like, how many number of balls are there in event A? There are 5 balls. So the n of A is 5, and over there we said like n of s is 8. So like over here, what do you call it? P of A, probability of A, will be n of A, number of you could say elements in A, divided by the number of elements in S. So that's 5 over 8. So that is the probability of us getting a green ball. And I guess that is, from the looks of it, a high probability. Anyway, let's move on to the second. Oh, what did I do? I accidentally copied a bit too much. Let's copy that again. Okay, so that was the first part, right? And now let's move on to the second part. So part number 2 is that what is the probability that the ball is red? So part number 2 is event B. I'm going to name it, right? We're going to name it, or you know what, forget it. Let's name it event C for just like fun. Anyway, event C. What is event C? The ball is red. The ball is red. So how many balls are there that are red? There are approximately 3 balls. R1, R2, and R3. According to the info that we are given right here, it says 3 red balls in a box. So that means that like number of elements in C will be 3, right? Because there are 3 red balls. And like that means that to get P of C, or probability of C, we will divide the number of elements in C by the number of elements in the sample space, which is 3/8 in this case. So yes, just like you could see from the amount, the green balls have a higher chance of being taken out compared to the red balls. Yeah. Alright, that's 3 questions down, and let's get the 4th. So, what is question number 4? Question number 4, it says that a fair coin is tossed 3 times, and it asks, like, what is the probability that we get 1 tail, or what is the probability that we get at least 1 head? So the coin is tossed thrice, and like each time it's tossed, we can either get a head or a tail. And we have to, like, kind of think of every possibility. And what will that be? Like, it could either be a head, like all 3 times we get a head, right? Every time we flip, we get head. Or we could get head, head, and then tail. Or we could get head, tail, head. Or we could get tail, head, head. Or we could get tail, head, tail. Or we could get tail, tail, head. Or we could get what's one more thing? What's one more thing? We could get tail, tail, tail. Or we could get head, tail, tail. I think that is pretty much it. Yep, that's pretty much it. So this like covers it up. So this is our sample. Oh, oopsies. Sample set. And yes, those brackets just do not look good. What should I do about that? Okay, I think I got a better hang of it now. Anyway, so we have like 8 options, right? Like 1, 2, 3, 4, 5, 6, 7, 8. So there are like 8 possibilities total. So n of s will be equal to 8, right? Yeah. Yes. Now, what? Let's move on to the first. Like, what is the first event? Event number 1 is we get 1 tail. How? Like, what do we do? You can see the events. Like, we've listed kind of every possible outcome over here in like the sample set. So or sample space, we're just going to take whatever outcomes have like at least 1 tail, or like just 1 tail actually, and yeah, we're just going to put it in that event or in the set for that event. So event A is number 1. We have event A. I'm going to name it, and event A is equal to 1. Like, we just need the one outcomes with 1 tail at least, right? They are going to be included in event A, so, or it's set for event A. So event A is equal to, now let's look at the options over here. We have like 1, 2, and 3. So we have 3 options where there is like 1 tail, and like that's it. So like, actually, wait a minute, we need to write them down, I think. Oops. So we have HHT, and we have HTH, oops, and we have THH, right? Yep, HTH and THH. So that's pretty much it for event A. And like, what are the number of elements in event A? They are 3. 1, 2, 3. So yeah, that's 3. And like, NS is, we said number of elements in S is 8, so like P of A, or probability of A, will be equal to N of A, or number of elements in A, divided by the number of elements in the sample space, so that it's going to be 3 divided by 8. And yeah, there we have it. And that's the probability of us getting one tail, 3/8. Yeah, maybe we'll just like paste it right here somewhere, right here. And yeah, so like next question, or you could say, I mean, next part. We'll use this one this time. This one. Okay, so the next part is part number 2 is what, like, in what case will we get at least one head. I'm gonna name this event D, and it will be equal to the events, you could say the particular outcomes which contain at least one head. So, oops, I have not written those spellings right. At least one head. That is better. And yeah, so yeah, let's like go over here and let's look at the ones that have at least one head, right? Like the triple H is 1, double HT is 1, HTH is 1, THH is 1, THT is 1, TTH is 1, HTT is 1. There are a lot actually, so I don't know what to do, but actually, yeah, I'm just gonna write them down there. So like we have event D is equal to triple H because it has at least one head. Then we also have like double HT, and then we have HTH. We're basically supposed to get 7 because, well, it's kind of common sense if you guys look at it, like in the sense that, you know, only one of them, like the triple tail, will only get triple tail once, right? Or like there's only one chance of getting that, right? So the rest, they're like 8 in total, so that means there's 7 in all, right? But like we're just gonna, for the sake of this video, write all the outcomes which contain head, at least one head, you could say. So we have like triple H, double H, and HTH. Yeah. Then we have T double H, and then we have THT. T double H, and we have THT. And we probably have some more. We have double TH and H double T. Double TH and H double T. And as you guys can see, I've already told you guys we were gonna end up with like 7, so we did. Why are these brackets just so bad? Anyway, what should I do? Comment down below. Anyway, the number of elements in D will be 7 because 1, 2, 3, 4. Actually, yeah, 1, 2, 3 multiplied by 2 because there are 3 over here, so that's 6. 6 plus 1 is 7. Probably didn't need to know that, did you? Anyway, so like the probability of D, because the number of elements in D are 7, and the probability of D is equal to number of elements in D divided by the number of elements in sample space. That is going to be 7 over 8. So like we have a high chance of pulling a, what is it? Actually, like, yeah, we have a high chance of at least getting one head when we like toss a coin 3 times. Anyway, next question. We have done 4. Come on, switch. Yes. Okay, so question number 5. Just gonna be putting it right there. Yeah. Yeah. Question number 5, or experiment number 5, let's say. So we roll a die, or a dice, in other words. A dice is rolled. A die is rolled. The top shows events that can happen, or that they want to find the probability of happening. 3 or 4 dots, or dots less than 5. So, okay, first of all, like, you know, a dice, it has like 6 dots, right? So the sample space for this one will be like the set will be s is equal to 1, 2, 3, 4, 5, 6, because these are the possibilities. We could get a dot, we could get a dot, we could get two dots, we could get any number of dots all the way to from 1 to 6. So these are the possibilities, and it asks what is the possibility that we get a 3 or a 4 dots. So like let's create an event. Number one, event, I'm gonna name it event J. Event J is equal to how many dots? 3 or 4 dots. So the possibilities of us getting 3 or 4 dots, that's event J. So like we have 3 or 4, right? So event J will be equal to 3 comma 4, right? And that means number of elements in J, in set J, will be 2, 3, and 4, or 3 or 4. So oh, by the way, I just realized I didn't get the number of elements in S. But anyway, number of elements in S will be 6, right? Because 1, 2, 3, 4, 5, 6. There's 6 elements over here. So yeah. Yeah. Anyway, number of elements in J are 2. So the probability of J will be number of elements in J divided by number of elements in S, which will be equal to 2 over 6, and you know that we can simplify this and we can get 1 over 3. So we get 1 over 3. So we have 1/3 of a chance of pulling 3 or 4 dots, if you ever roll the dice, that is. Anyway, now let's talk about the second part of the question. So what is that? Okay, so part number 2, I'm going to use this color. Yeah, so change the pen. Part number 2, I'm going to name this event K is equal to dots less than 5. Dots less than 5. So it could be anything that's less than 5. Now, what are the numbers that are less than 5 in, a dice? Like from our sample set, we can kind of look at that, and I mean it's pretty simple, isn't it? That what is less than 5 over here? We have 1, 2, 3, and 4. So all those are what make up set event K. So we have 1, 2, 3, and 4. And yeah, so like number of elements in K, in set K, will be 4 elements, right? And like the probability of K will be equal to number of elements in K ratio number of elements in the sample space, which will be 4 over 6, which again you can see we can simplify these as well. 2 2s are 4, 2 3s are 6, so 2 over 3. So like yeah, we have a higher probability for event number 2 happening or taking place than event number 1. Not that it really matters, does it? Anyway, that is our 5th question, I believe. So we have done like 5 questions already. Look at that. Yeah, so just gonna rearrange this bit. Yeah, I think that's enough. So question number 6. Question number 6 is from a box containing slips numbered 1, 2, 3, 4 all the way to 5, meaning, okay, I mean like it said 1, 2, 3 all the way to 5, so there's only one number left, isn't that? That's 4. But anyway, 1, 2, 3, 4, 5. One slip is picked up. Events that are happening. What are the chances that the number on the slip is a prime number, and what are the chances that the number on the slip is a multiple of 3? So first of all, what is the sample space? We have 1, 2, 3, 4, and 5. Yes, I'm not going to write those 3 dots just for one number that's called 4. But anyway, we have like numbers all the way from 1 to 5. So the number like of elements in S, or the sample space, will be 5, right? Now, what is the first part, you could say. Let's look at this one. Okay, this is not such a good color, but okay, we tried anyway. Yeah, so let's try this. We're gonna call this event. What should we name it? Event E. Event E is equal to, what are the chances that the number on the slip is a prime number? Prime number. Prime number. Okay, so like don't think about like prime number like one, like what do you call it, 2 all the way to whatever, like infinity and stuff. It's just asking prime number that's within the range of like 1 to 5. So like prime numbers, what are like prime numbers in the sample set over here? We can like, you know, just look at the sample set, and 1 is not a prime number, 4 is not a prime number, 2, 3, and 5 are all prime numbers. So all 3 of them make up the event E, and like number of elements in event E are going to be 3 in this case. So the probability of event E taking place will be number of elements in event E divided by, or ratio, the number of elements in the sample space. What is this? Okay, the number of elements in the sample space is 5, so we have like 3 over 5. Well, yeah, makes sense. So we have like a high chance of getting a prime number. And now the number on the slip is a multiple of 3. That's the second case. So like the second event, you could call it. So event number 2, or you know what should we name it this time? Event F is equal to multiple, number on the slip being a multiple. Oh, oops, I said multiply. Multiple of 3. So just by looking at the sample space, what is a multiple of 3 in our like sample space? We have 1, 2, 3, 4, and 5. We don't even have 6, so that means there's only 3 as the multiple. And that means that the number of elements in event F are 1. So that means probability of event F taking place is equal to number of elements in it. What do you call it? Event F, ratio number of elements in the sample space, which gives us 1 over 5. So 1/5 of a probability that we get a multiple of 3. Yeah, so that's pretty much it. And now I believe we have done the 6th question now. Yes, we have. Okay, so question number 6 is down already. Alrighty, so let's get to question number 7. Question number 7, what does it state? It states that 2 dice are rolled, one red and the other blue, and yeah, they're rolled simultaneously. So much for details. The numbers of dots on the tops are added. The total of the 2 scores is like, what's the probability that it's 5, what's the probability that it's 7, and 11. So what's our sample set? Our sample set, or like sample space, is, yeah, it's you could say like we can get one, like it works like this, that we can get, like when we roll the dots, we can either get 1 dot on both of their tops, so we can say like 1 1. We can either get 1 dot on 1 on the first and then 2 on the second, or we can get 1 on the first and 3 on the second, on and on, like all the way to 6, because, well, that's the maximum that you can get in a dice. But anyway, 1 and 4, 1 and 5, 1 and 6. So this is the maximum. We can either get 2 and 1, like meaning 2 in the first and 1 in the second. Yes, it's a possibility. I know you didn't think so, but guess what? It is. 2 and 3, 2 and 4, 2 and 5, 2 and 6, 3 and 1, 3 and 2, 3 and 3, 3 and 4, what did I do? 3 and 4, 3 and 5, 3 and 6, 4 and 1, 4 and 2, 4 and 3, 4 and 4, 4 and 5, I'm just gonna fix this one. I'm a bit sorry for messy handwriting, but yeah, 4 and 4, 4 and 5, 4 and 6, 5, 1, 5, 2, okay, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. That is all of them. So these are the 6 possibility, what do you call it, 36 possibilities, because if you count to the right 1, 2, 3, 4, 5, 6, and if you count down 1, 2, 3, 4, 5, 6, so we get 36 possibilities, and that means the number of the number of elements in the sample space are 36. Now let's move on to our first case. In how many cases can we get the sum of both of the scores, the total of the scores, to be 5? So yeah, case number 1 is event, let's name it event S is equal to D1, you could say dice 1, the number on dice 1 plus number on the top of dice 2 is equal to 5. Okay, so the event S will be equal to, how many of these combinations you could say add up to 5? Well, we have 1 and 4, and we have its opposite 4 and 1 over here, and we have 2 and 3, and we have 3 and 2. And yeah, that's pretty much it. So we have 1 and 4, and its opposite 4 and 1, and we have 2 and 3, and its opposite 3 and 2. So that's pretty much it for four different combinations which give us 5. So number of elements in the, oh, actually this does make it confusing, doesn't it? I'm a bit sorry, guys. Feels like I have messed up a bit, quite a bit. Why not? Let's name it something better. Let's name it let's name it event U. Yes, event U. That's a good name. Yep. So number of elements in event U. I know this sounds awkward because I literally just named it event S a moment ago, but I'm sorry, I didn't keep in mind that the sample space is also represented by the capital letter S. I thought it was funny, but it wasn't. Anyway, number of elements in event U are 4. So the probability of event U taking place is equal to the number of elements in event U divided by the number of elements in event S, which will be equal to 4 over 36. So as we know the table of 4, we know that 4 4 ones are 4, 4 nines are 36, so we get 1 over 9, and that means it has we have like a 1/9 of a chance at getting like the score to add up to 5. Now let's look at the second case. The second case is like, what are the chances that we could get the score add up to 7? Yeah, so let's use this color right here. So let's name it event H. Let's name it event H. Event H is D1 plus D2 is equal to 7. So what are the possibilities? Well, event H will, like, what are the possibilities now? Like, without even going to the sample space, just thinking about it in my head, I can tell, and so should you be able to, that 1 and 6 is a possibility because 1 and 6 can sum up to 7. 6 and 1, obviously the opposite of it, will also sum up to 7, right? 2 and 5, it will also sum up to 7. 5 and 2 will also sum up to 7. 3 and 4 will also sum up to 7, and lastly we have 4 and 3. I can't think of any other ones, but if you guys can, first of all, you've beat me, and second, yeah, you've beat me to it. But yeah, comment down below if you have. Obviously I don't think so, you have, but still, just saying. Anyway, yeah, so like you can see right here, these are like basically possibilities that we could get a 7, right? Like these are the ways in which we could. So like possible outcomes are these are like, how many of them are they? There's 6. 1 2 3 4 5 6. So number of elements in event H are 6. To get the probability of event H to take place, we divide the number of elements in event H by the number of elements in the sample space, which gives us 6 over 36. So since we know the table, 6 ones are 6 and 6 are 36, we get 1 over 6, and that means we have 1/6 of a chance at getting the scores to total up to 7. Okay, so now, or total to 7. Now, now we have like the last case. Which color? We'll just choose this lame gray color for now. Anyway, yeah, so the number third event, what should we name it now? What should we call it? Event, what's the letter we haven't used yet? Let's name it event N is equal to D1 plus D2 is equal to 11. So what are the possibilities that we get to N11? There are only 2 possibilities that I can think of right now, because I'm pretty sure there are only 2, but anyway, we get like 5 and 6, 5 and 6, and 6 and 5. So that's 2 possibilities. So the number of like elements in event N are 2. So like what do you call it? The probability of event N taking place is equal to number of elements in event N divided by number of elements in event S, I mean sample space S. So that's like 2 over 36 is equal to, divide that, so we know, 2 can divide that, 2 ones are 2 and 2 18s are 36, so we get 1 over 18. So that means we have 1/18th of a chance at getting the scores to sum up to 11. And yeah, that's the 7th question. Alright, so now let's move on to our last question. Like, yeah, from here, like question number 8. So question number 8, well, it's not like the last of this exercise, I don't think so, but like the last of the ones that I could copy. But anyway, you guys don't worry about that. Let's focus over here. So a bag contains 40 balls, out of which 5 are green, 15 are black, and the remaining are yellow. A ball is taken out of the bag. What is the possibility that the ball is black, green, or not green? Okay, so like first of all we need to understand, like, you know, the sample set. We need to understand what it gave us. We need to get the sample set. We need to get like the number of elements in the sample set and how many types of events are there. So like first of all, number of elements in the sample set are 40 because he said that 40 balls. And what is the sample set? It's 40 balls, but 5 of them are green, so I'm gonna name it in the green color. I'm gonna name it G1, G2, G3, G4, G5, and 15 of them are black. So like B1, B2, B3, all the way to B15 are black, and then the remaining are yellow. So, okay, first of all, how do we find the number of yellow balls? Well, you can see 40 is the total over here, right? And if 5 of the balls are green and 15 of them are black, the rest are yellow. So if we add the number of green and black balls, that is 5 plus 15, which is equal to 20, and then subtract that part out of the total balls, which are 40, so 40 minus 20, we get the number of balls that are yellow, which means there are 20 balls, yellow balls. So we have like Y1, Y2, Y3, all the way to Y20. So yeah, that's pretty much like our solution set. I mean, sorry, sample space. What am I saying? Solution set. Yeah. So this is our sample space, and yeah, we have like 40 balls. Now, what is the first event? Event number 1. Oops, what did I do? Okay, so event number 1. Let's choose a good color. We haven't used this one. So event number 1. I mean, like I'll name it event number, let's say Q is equal to black. I'm gonna name it black. Basically, it means the black balls. Like, what is the possibility of there being a black ball? So like event Q will be equal to how many black balls are there? There are 15 black balls, so that means B1, B2, B3, all the way to B15. Okay, so these are the number of black balls, and I mean, these are the black balls, and the number of black balls is going to be like n of Q, event Q, which will be 15. Now, the P of Q, or the probability of Q, will be equal to number of elements in Q divided by number of elements in the sample space, which will be equal to 15 divided by 40, which should be equal to, obviously you guys know, something cuts from here. What did I do? I used the brown color by accident. Oops. So, yeah, here we have it. So 5 3s are and 5 8s are. So we have like a 3/8 of a probability that the ball is gonna be black. So that's one scenario, one event. What am I doing? Cancel that. Oh, great. Try to do it again. Anyway, there we go. Okay, so okay, part number 2. Let's move on to the second. What is the second part? Event, we'll call it event X, will be equal to the ball is green, so I'm going to name it green. So event X is equal to G1, G2, G3, G4, G5. Because why? Because that is the number of green balls, because you can see it over here, it says out of which 5 are green. So this is the number of green balls. Okay, wait, these are, sorry, I did it again. This is like the set of green balls. These are the only green balls. They can be G1, G2, G3, and then the number of like green balls is equal to 5. And yeah, so like the probability of event X taking place is equal to the number of elements in event X, ratio number of elements in the sample space. I caught my mistake a bit. Okay, so what I'm gonna do is just gonna probably erase this one. I mean, it looks okay, but then I kind of switched in the middle, so kind of really sorry for that. Yep, so there we have it. So like 5 over 40, that, and like when we divide this, simplify this, we get 5 ones are 5, 5 like 8s are 40, so we have 1/8 of a chance of getting a green ball. Yep, and now let's talk about what is the possibility that we get a ball that is not green. So number 3, let's name it event W is equal to not green. Okay, so what is the possibility that a ball is not green? Okay, so how do we find the number of balls that are not green, or all the balls that are included in the not green section? Well, subtract the green ones out of the total and we'll get the remaining, right? So when we do that, like we have like 40 as a total and we have 5 green balls, so when we subtract 5 out of 40, we get 35, and that means 35 balls are not green. That means they're either black or yellow, but that doesn't matter because we're not concerned about that. Anyway, so like what we now know is that event W is equal to like the black balls from like B1 to B2, B3, all the way to B15, and the 20 yellow balls, so Y1, Y2, Y3, all the way to Y20. So yeah, anyway, that makes like 35 balls. So that means number of elements in event W are 20. Okay, so like, oh wait, what am I doing? 35, sorry, my bad, I don't know why I said that. It's 35, clearly 35, it's just my bad. But anyway, probability of W will be equal to number of elements in W divided by number of elements in sample space, which will be equal to 35 over 40. And yes, from dividing we know like we know that 5 7s are 35 and 5 8s are 40, so 7 over 8. So we have like a high chance that, you know, almost like a guaranteed chance that the ball that we pull will not be green. But anyway, yeah, that's the 8th question. Okay, so now let's do question number 9. So question number 9, what does it ask us to do? So question number 9, first of all, it states that one chit out of 30 containing the names of 30 students of a class of 18 boys and 12 girls is taken out at random for denomination as the monitor of the class. Events that are happening are, what are the possibilities that the monitor is a boy, and what are the possibilities that the monitor is a girl? Well, first of all, what is the sample space? The sample space consists of, what does it consist of? It consists of B1, B2, B3, all the boys, all the way from B1 to B18, and I'm going to move it down so that it'll probably look better, a lot better. And it consists of all the girls from G1, G2, G3, all the way to G12. So yeah, so the number of elements in sample space are 30, as we already know, because, well, we were told that at 30 students. Anyway, yeah, so that's number of elements in the sample space. Now, like in the first case, where is it? Yeah, so okay, you know what, we'll choose a different color, probably this one. In the first case, or maybe we'll choose like this color. What's the first case? The first case is the boy is a monitor. The boy is the monitor, or the monitor is a boy. In other words, whatever way you want to call it. So number 1, we're gonna name it event G is equal to boy. So, like, yeah, boy, or monitor is a boy. So how many boys are there? There are 18 boys. So event G will contain all 18 of them. So event G is equal to B1, B2, B3, all the way to B18. Like this. Yeah, no. Okay, you know what? I'm just gonna erase this. Probably draw it again. That's just not good. That's better. Anyway, yeah, so that's enough of that. Let's get down to business. So number of boys, or should I say number of elements in event G are 18. So the probability of event G taking place is n, or number of elements in event G, divided by number of elements in event in the sample space. I mean, what am I saying? 18 over 30. So, like, as we know for ourselves that 6 3s are 18 and 6 5s are 30, then 3 over 5. The boys have a, well, higher chance, I'm pretty sure, than the girls in this case. So now let's get on with case number 2 for the girls. For the girls. Yeah, so case number 2, or event 2. What is the chances that the monitor is a girl? So I'm going to name it like event B is equal to girl. So, like, how many girls are there? Let's list them down first. So event B is equal to G1, G2, G3, all the way, well, I wasn't going to name all of them. I mean, list all of them. Did you think so? Yeah. So, like, we have, like, 12 girls, right? So G12, all the way from G1 to G12. And that means that the number of elements in event B is 12. Or like R12. So the probability of event B taking place is equal to the number of elements in event B divided by the number of elements in the sample space. So that's 12 over 30 is equal to 6 2s are 12 and 6 5s are 30. So 2 over 5. So that means that the boys have a bit of a higher chance than the girls in this case at being the monitor, but it's not like anyone's concerned, right? Like, I mean, it's just being a monitor, you know, being a snitch. Anyway, no one cares about that, do they? Yeah, so now let's move on to the last question of this exercise. Question number 10. Okay, so the 10th experiment in our final for this session is a coin is tossed 4 times, and the tops show, like, the events. What are the chances that all we get all heads, and what are the chances that we get 2 heads and 2 tails? So first let's make up the sample space for this, right? So the sample space now, the coin is tossed 4 times, alright? And we have 2 possibilities each time. We can either get a head or a tail. So the very first possibility is that all of them are heads, so 4 heads. We could also get 3 heads and a tail. We could get 2 heads, a tail, and then another head. We could get a head, tail, and then 2 heads like this. We could also so we could also get a head, what is it called? A tail. Oops, what am I doing? Head, tail, and tail. And then we could get a head, a tail, a head, a tail, or we could get a head, a tail, a tail, a head, or we could get a tail, a head, a tail, a head, or we could get a tail, 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 tail. You could get a tail, 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 head. You could get a tail, tail, head, head. Oops, what am I doing? I mean, this is a possibility, but not right now. I don't think so. A head, a tail, and then a tail, a head, a tail, tail. And then, yeah, we could also have, what else is a possibility? We could have a tail, a head, a head, a tail, head, tail, head, a tail, head, head, tail, and what else? A head, a tail. Oh, I think that is pretty much it. I think. So it looks like we have repeated something which we're about to erase from here and from history. No, I'm just kidding. Anyway, we kind of duplicated T. Let's just see it. Yeah, TH. So just got rid of that. But yeah, so I noticed that what we're missing is we don't have an H, T, and we don't have a T triple H. So now we do. So this makes 1, 2, 3, 4, and 1, 2, 3, 4. We get 16. Why do these look so bad? We get 16 elements in the sample set. So n of s will be equal to 16. Okay, now let's look at the first case. Case number 1, what does it say? Case number 1 says, find the possibility, chances of getting all heads. Well, I mean, this is kind of simple, right? Because it's there's only one possibility that you can get quadruple heads, right? So that's this quadruple H. So I'm gonna write event number 1, I'm gonna name it event number T, or event T, which is all heads. Okay, so event T, all heads means H, 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 and H, or quadruple H in other words. So number of elements in event T is 1, and the probability of event T taking place is number of elements in event T divided by number of elements in the sample set, or sample space, which gives us 1 over 16. So we have a 16th chance or possibility of getting all heads, right? And what is event number 2? Event number 2, what did I do? Let me choose a good color. I don't know any good colors actually. I don't know, they're all the same. Yeah, I'm just going to choose this. So event number 2, what is the possibility? Oh, what did I do? Okay, there we go. So what is the possibility that we get 2 heads and 2 tails? It didn't say which order, so that means, like, let's name it event H is equal to 2 heads and 2 tails, so I'm going to write 2H, 2T, and then event H. What are the different types of, like, combinations, you could say, right, that we can get in, like, that have both like 2 H's and 2 T's. So we have like 3 from here, we have 3 from here, and we have 3 from there. So we have like 6, I think. 2, 4, 6, 5. Where's 5? 5 and 6. Okay, so yeah, so we have like H, H, T, T, and we have H double T, H, and we have H, T, H, T. Same, we can like reverse this. H, H, we have T, H, H, T, and we have T, H, T, H. So these are the elements in the sample, what am I saying, event H, for event H. So number of elements in event H are 6. Now the probability of event H taking place is equal to the number of elements in event H, or ratio number of elements in the sample space, which is 6 over 16. We know that we can divide this stuff, right? So we get 2 3s are and 2 8s are, so like 3 over 8. So we have a 3/8 of a chance of getting, what is it? What was this again? Yeah, 2 heads and 2 tails. So like together. So at least it's better than, you know, getting all heads. But yeah, it's still seldom. Anyway, that is it for this. You could say tutorial, or this session. So in this session you just learned how to calculate probability, and if you found this helpful, then leave a like and subscribe to my channel for more content like this, because yes, I am trying to teach you guys whatever I learned, and yeah, I'm trying to build you guys' concept by first founding my own and then, like, you know, teaching you guys. So as always, peace out and see you in the next video.